Aggressive exhaust port opening refers to the practice of opening the exhaust port earlier or wider during the engine's cycle. This approach allows exhaust gases to exit the combustion chamber more quickly, reducing back pressure and improving the engine's ability to take in a fresh air-fuel mixture. By optimizing the timing and size of the exhaust port, engineers can enhance overall engine performance, particularly in terms of power output and efficiency. However, this technique requires careful calibration to avoid potential drawbacks, such as increased emissions or reduced torque at lower speeds. Exhaust scavenging refers to the process of efficiently removing burnt gases from an engine's cylinder after combustion. When exhaust flow is maximized, it helps clear out these gases more completely, making room for a fresh air-fuel mixture. This is crucial because any leftover exhaust can dilute the incoming charge, reducing engine performance and efficiency. Effective scavenging not only improves power output, but also helps lower emissions by ensuring more complete combustion in each cycle. Intake and exhaust ports serve distinct roles in an engine's operation, each with specific requirements. The intake port is designed to efficiently deliver the air-fuel mixture into the combustion chamber, prioritizing smooth airflow and minimal resistance. In contrast, the exhaust port must expel hot gases quickly and effectively after combustion. Because exhaust gases expand and increase in volume due to high temperatures, the exhaust port typically needs to be larger to accommodate this greater volume. This ensures that back pressure is minimized, allowing the engine to operate smoothly and efficiently. Increasing the size of the exhaust port plays a crucial role in engine performance. A larger exhaust port allows burnt gases to exit the combustion chamber more efficiently, a process known as scavenging. Improved scavenging helps clear out residual gases, which can otherwise dilute the incoming air-fuel mixture and reduce power output. By minimizing these leftover gases, the engine can achieve more complete combustion in each cycle. This leads to better efficiency and overall improved performance. When beginning the porting process, it's important to choose the right tools for the job. Various rotary tools and burrs are commonly used to shape and smooth engine ports. For exhaust work, selecting larger tree-shaped burrs is especially effective. These burrs allow for efficient material removal and help maintain the desired contours within the exhaust passages. Using the correct burr size and shape not only speeds up the process, but also ensures a more precise and consistent result. To safely open exhaust ports using larger tree burrs, begin by ensuring the engine is securely mounted and all necessary protective gear is worn. Select a tree burr of appropriate size, making sure it matches the material and dimensions of the port. Work slowly and steadily, applying light pressure to avoid removing too much material at once. Frequently pause to inspect your progress and clear away debris, which helps maintain accuracy and prevents overheating. Always keep your hands clear of the rotating burr and remain attentive to avoid accidental slips or damage to the port. Accurately measuring exhaust and intake port sizes is essential for achieving optimal engine performance. Use precision tools like calipers or porting templates to assess the cross-sectional area of each port. Compare these measurements to manufacturer specifications or proven performance guidelines to ensure a balanced flow between intake and exhaust. Avoid removing excessive material, as overporting can disrupt airflow velocity and reduce engine efficiency. Striving for a harmonious balance helps maintain power and reliability. When enlarging exhaust ports, it's important to avoid removing too much material, as this can weaken the cylinder head and negatively affect engine performance. Common mistakes include grinding past the gasket line, creating uneven surfaces, or thinning the port walls excessively. Signs of excessive material removal may include visible cracks, unusually thin port walls, or a noticeable drop in engine compression. Always measure carefully and compare your work to manufacturer specifications to ensure structural integrity is maintained. Recognizing these warning signs early can help prevent costly repairs and maintain optimal engine function. Improved exhaust scavenging allows spent gases to exit the combustion chamber more efficiently, making room for a fresh air-fuel mixture. This process reduces residual pressure and heat, which can otherwise hinder the next combustion cycle. As a result, the engine breathes more freely, leading to quicker throttle response and increased power output. Enhanced scavenging also helps optimize fuel combustion, contributing to smoother and more responsive engine performance. Aggressive exhaust port modifications can offer significant performance gains, but they also come with notable risks and challenges. It's essential to thoroughly research and understand the specific needs of your engine before making any changes. Consulting with experienced professionals and using precise measurements can help avoid costly mistakes. Remember that while increased airflow can boost power, it may also impact reliability and drivability. Carefully weigh the potential benefits against the possible drawbacks to ensure the modifications align with your goals.